This is solving systems of equations algebraically. We're going to use this method when you have two different systems of equations, both with two variables, two of the same variables. Our two algebraic methods of doing this are substitution and elimination. So to do elimination, you have to multiply one equation so that one variable in that equation then cancels out the same variable in the other equation. The example we have here is 2y plus 3x equals 6 and negative y plus x equals 3. I multiplied the second equation by 2 to have a positive 2y cancel out the negative 2y. Then as you can see, we add the other variables, so 3x plus negative 2x is x, and then 6 plus 6 is 12, so x equals 12, and we'd go back and solve for y. The first example we have of this is 3x equals 2y plus 2 and 3 equals 2y minus x. I decided to multiply the second equation by negative 1 so that I could then get a negative 2y to cancel out the positive 2y in the first equation. Here I just wrote the first equation back down so we could easily add them up, and when you add them you get 3x minus 3 equals x plus 2. From here we're just going to solve for x just like any other equation. So the first thing we're going to do is add 3 to both sides to try to get that x by itself. Then we're going to subtract x to get 2x. Then since we have 2x equals 5, we just want 1x. We're going to divide by 2 to get x by itself. Now since we have what x equals, we can then plug in that in either of the two equations to get what y equals. I chose to use 3x equals 2y plus 2, and for x I just plugged in 2.5, and again just solve that like a normal equation. So 3 times 2.5 is 7.5, and so I subtracted 2 from both sides to get that y by itself, and then we get 2y equals 5.5, and I divided by 2 to get y by itself, so we get y equals 5.5 over 2. The next example we have of elimination is 3x plus 12 equals 3 and x minus 2 equals 4. As you can see, I multiplied the second equation by a negative 3 to cancel out that positive 3x so that we have a negative and a positive 3x. From here, again, I moved the first equation back down so we could easily see how that adds up. So the x's cancel out each other. 6 plus 12 is 18. And then a negative 12y plus 3y is negative 9y. I then multiplied by a negative 1 to get y positive. So then we get 9y equals negative 18. And to get y by itself, we then have to divide by 9. So we get y equals negative 2. From here, we're going to solve for x using the y value that we just got. So I used the equation 3x plus 12 equals 3y. And then I plugged in negative 2 for y because that's what we just got in the previous step. From here, again, I just solved it like a normal equation, added 12 on both sides to get x by itself, and then since we have 3x, we're going to divide by 3 to just get 1x, so we get x equals negative 6. The second method for solving systems of equations algebraically is substitution, and we use this when we're given what one variable already equals. So here that variable would be what x is, because we have x equals y plus 5. So we would plug in what x equals in the first equation with y plus 5. So in this case we'd have 3y equals 2, and then parentheses y plus 5 plus 3.
So for the substitution side of things, we're basically going to be taking one equation and substituting that into another equation and then solving that equation. So in this example, we have 2y equals x plus 10 and x equals y plus 5. What we'll want to start by doing is taking x equals y plus 5 and substituting that value of x into the x in the equation 2y equals x plus 10. When we do this, we're going to end up with 2y equals y plus 5 plus 10. We're going to want to combine like terms by adding our 5 and our 10 to get 15. So we'll end up with 2y equals y plus 15. We can then subtract y from each side of the equation to get a single standing alone y, which would be 15. Now that we know that y equals 15, we're going to have to stick 15 back into the equation to find x. So as you can see, we put 15 in for the position of y, and we're going to have to take 2 times 15 equals x plus 10. That leaves us with 30 equals x plus 10. From that, we can subtract 10 from each side to get the x term alone, which x equals 20 once we do that. Thus, x equals 20 and y equals 15 for this equation. Our next set of equations is 2y equals x minus 10 and y equals x plus 20. This set is going to be a little more tricky to solve as we have to substitute in for 2y instead of just for x. We're going to start by substituting in x plus 20 for y in the top equation to get 2 times x plus 20 equals x minus 10. We are then going to want to multiply 2 times x plus 20. That will get us 2x plus 40 equals x minus 10. Once we have that, we're going to want to subtract 40 and get x by itself. Once that has been completed, that'll yield us with 2x equals x minus 50. We're going to then want to subtract x to get x alone. From that, we'll get x equals negative 50. So now we can put in x to solve for y. So what we can do is put in negative 50 where the x should have been. So 2y equals negative 50 minus 10. We're going to combine like terms to get 2y equals negative 60. We can then divide by 2 to get y alone. Y then equals negative 30 and x equals negative 50, resulting in our answer. Well, that wraps up our tutorial on how to solve systems of equations algebraically using the elimination and substitution methods. Thanks for watching.